So, hi everyone, I'm Fotis Adamakis, as you can tell, I'm Greek from my name, but I'm living in Barcelona for the last 3 years already. I have attended almost every meetup so far, and I learned always something new. In one of the meetups last December, someone mentioned feature slice architecture, which inspired my own talk about front-end architecture. Front-end architecture is a strange topic. On one hand, it's hard and complicated, but on the other, everyone has an opinion and wants to be involved with the decisions. In my case, I have worked many years, almost 15 in front-end. I have seen some things that work, many things that don't work at all, and I believe after many iterations, I have found architecture that works really well. And this is what I'm sharing with you today. Of course, I don't take full credits. This is inspired by feature slice architecture, as I said, Next architecture, and some feedback I got from some friends, which is what I hope we are doing today as well. We will have a Q&A at the end. If you have any questions or feedback, please let me know. I think we will have pizzas there, so I'll be somewhere around there with pizzas. So what is the best front-end architecture? Well, it depends. I bet you could see this coming. Let me explain with a graph. On one axis, we have project complexity, how big is your project basically, and on the other, we have pain. Pain is an indicator of code quality, and it is also measured in WTS per minute. The correlation between the two is not linear. The more code you add, the more dependencies you have between the code, which increase pain exponentially. There is a section on the left that everyone is happy. The code base is small. You can easily understand what's going on. You can easily refactor things around. You can take some terrible decision and it will not actually matter simply because your code base is easy to understand anyway. Unfortunately, we evaluate front-end frameworks with projects in this category. It's usually a to-do application that doesn't expose real-life problems. On the other side, we have really big code bases. And the only known solution to this category are micro-frontends. Is someone experienced with micro-frontends? Can I see some hands? Okay, and 5 people. And are you happy with micro-frontends? Is someone happy? 2 people. You should talk to the guys to make a talk. I would love your insights because my experience is not that good. I'm not against them, but I'm just saying that they're not a silver bullet. When you have a big code base, you have a lot of issues, as you can tell. Then you introduce micro-frontends and you need to solve again routing, state management, performance issues, duplicated code on top of your existing projects. So today we will not talk about micro-frontends. I hope my friends will next time. And we will not talk about tiny projects as well. We will talk about what's in between. And probably most of us are working on this kind of projects every day. First, let's see about what the big frameworks think about this matter. React, this is taken officially out of their docs, doesn't have an opinion. It basically says, I will do things reactive, you figure out architecture, state management, routing, etc. Which I respect. There are more opinionated frameworks if you want something like that. There are Gatsby, Next, Remix, and a lot of other frameworks if you want something more opinionated. Then we have Vue. Vue also doesn't have an opinion, but they don't acknowledge this at all in their documentation. The only speaker that had a talk in the last Vue.js Amsterdam conference, which is the biggest Vue conference in the world, proposed a flat folder structure and having the component name as a prefix in order to group related components together. Of course, he used to-do application to demonstrate this, and you can tell that this will not work even for a medium-sized project. I don't think this will work having only one folder for all your components. Lastly, we have Angular. Angular has modules and feature modules by default, which is one of the things you need to learn, and many people find it hard to get started with Angular because you have to learn a lot of things. But Angular is actually right. Having multiple dependent entities inside your code base is the key to having a reasonable architecture. So let me show you what works for me. Everything starts with a router. For me, it's important to have all the route declarations in one place. You can have its module declaring its own routes, but then if you have different access rights and dynamic declare roots, you cannot really tell what's happening. Having them all in one place makes some sense, and you can easily tell that when this file gets out of hands, I need to move to microfrontends probably. The router helps us map the entry point, which is the current URL, to a page component. So then we have pages, again, all in one place, but very important, page components should be lightweight. You just need to declare a layout, some components, that's it, nothing more. If you find yourself declaring too many things, just group them in another component and use that instead. Then we have layouts, components, and features. Layouts are very important to have a consistent look and feel across your whole application and remove a lot of boilerplate. Components is all global components of our application, and you know that global is not a good thing in programming. So you should actually avoid writing things there. It's not realistic to have it empty, but if you can, please go ahead. Because most of your code should be inside features. Features is the core of this architecture. Your whole application should be split into features and live here in multiple subfolders. I will come back to this in the next slide. Let me show you first some more folders that you are already familiar with, probably. We have assets for static assets, like images, fonts, and styles. We have lib for our configurations for third-party libraries. We have types. Usually you have some types, some global variables in your code, and you need to declare them somewhere so your types compiler doesn't complain, and this is the place to do that. And then we have tests, not for the spec files. I believe that the spec files should be right next to the component tests, but you often need something like mocks, helpers, and configuration, and this is the place for them. So let's expand a bit more in the features. We expect multiple subfolders here, as I said before. An example could be the profile. And inside each feature, we expect even more folders. We have API for our fetching logic. We have stores for our state management. We have components for this specific feature. We have components and types as well. And we also have an index file, which acts as a public interface for this component. Everyone should only import from this file, not directly. I know this is a bit messy, so let me convert it to a more familiar view. Let me repeat. It's the router that maps the URL to the pages. Then we have layouts, components, and features, and assets, lib, test, and types. Inside features, we have multiple subfolders, and each feature has API, stores, components, composables, types, and an index file. Two things here. I'm calling them features because modules is something else in Next and was causing some confusion. And every folder inside the feature is optional. You might not have fetch logic, you might not have state management. That's it. The only important thing is the mandatory thing is the index file, which asks as a public interface, as I said. It's a common practice in the React code bases, which I liked and I think it makes a lot of sense. It prevents it actually doesn't prevent circular dependencies. When you have an import from your module to another module, and that module imports from your module, you actually have a generic error that it's not that helpful. This pattern prevents that. And you also have, I think, prettier imports. You can enforce it with this rule, ESLint rule. And about page components, I said they need to be lightweight. This is what I'm talking about. This is view code. I hope it's easy to understand. In view components, we have three sections. We have script, template, and styles, which in this case are omitted. Everything imported or declared inside script will be automatically available in the template. And this template just has a layout, some components for the main content, some components for the sidebar. That's it, nothing more. So this architecture should work well in most of the cases. There is an optional but highly recommended step if you want to build a quality code base, and this is the introduction of a design system. We saw in the previous talk that a design system is a collection of components and guidelines. They are very important to have a quality code system. It is created by the design team, but implemented by the development team, and they need to work together which is the most important thing. I have worked in many companies that the design team and the development team are different silos and they don't talk to each other. Is one doing his own thing. Having a design system brings them together. Implementation can differ. There are many ways to do a design system. You can have something ready-made, like bit.dev, or you can have something zero-heist, or you can have a custom implementation. I will show you a custom implementation. It starts with the folder, the new folder that I added which I called Core UI, and we have some folders inside here as well. We have tokens with all our design tokens. This will be variables for colors, borders, or typography in CSS or SAS variables. We have helpers for all our mixins or code to do theming or everything else. Styles are global styles. The example will be the reset.css. Components is all the magic that we saw in the previous talk that's happening. We have three options here. One option is to having a third-party library like Bootstrap, Utify, or anything else. Adam said something in the previous talk that it works until it doesn't, which is also my experience. I think you shouldn't do that. I have spent a lot of time removing third-party libraries for big code bases, and I don't think it makes a lot of sense. You also have the option to do something custom, but it sounds hard, and it's actually even harder. I think you always spend even more time that you expect, and you need to solve a lot of things like accessibility, like interactions between components. That it's hard, it's very hard, but it's another option. And the third option is something hybrid, having a custom implementation based on a headless component library, which I think nowadays makes the most sense. A headless component library is a component library that has functionality but not styles. You take the functionality, but you need to write your styles according to your branding. And I believe this is the best way nowadays. The most popular and my favorite is Radix UI, if you want to check it out. And lastly, we have documentation. Again, a design system is more than components. You need to have guidelines to do branding, to do interactions, to do accessibility, and a lot of things. This is a place for them. And then you use a tool like Storybook or Gitbook to have them available for everyone. I think that was it. This was the theory, at least, but I do have a code base that uses this architecture. So, because theory doesn't work always in practice, so I will show you around the code base. It's a Twitter clone. Is it visible? It's more or less functional Twitter clone. We have the timeline, we can add tweets, we can have trends that we can go. This is also a search that you can search something. We can go inside the tweet, we can go to the trends, we can go to the explore, we can go to a profile, we can edit a profile. So this is more or less a clone of Twitter. So let me actually show you the code behind this. This is not the correct one, sorry. So everything starts with, who was paying attention? Routes, well done. I think I should go to the design system. Okay, did I break something? Everything starts with a router. We have an index file that we have a mapping from a name to a path. Then a path is mapped to a page component. We can also have some middlewares before that are also in this file. Again, I'm using Vue, but I hope the code is easy to understand. Then in pages, let's see the timeline page, for example. We have a simple component that has some imports. Everything, again, in the imports will be automatically available at the plate. We also have composable and the third-party library to do media queries. We declare a layout. We declare some content for the main content, some content for the sidebar. That's it, nothing more. Then we go to the layouts. An example is the 3-column layout. If you have a header that use many pages used, you shouldn't declare it probably to any page. This is a good place to reduce, a good way to reduce duplication. And if you have a container that the height is this, you shouldn't actually write it in every page, I think. Then we have components for our global components. Then features. Again, we have multiple features here. Let's see tweets, for example. We have an index file, which is the publish interface for the specific feature. Again, everyone should only import from here. We have API for our fetching logic. This is the main difference with a feature slice architecture. I don't like repositories, how it's done. I think initializing and injecting a repository inside every service, it's too much boilerplate for me. Having something simple like this makes more sense. Then we have some components, some composables, nothing more. Then we have assets for our static assets, just some images here. Then lib, I'm only using Axios, so this is the place to configure it. We have test, we have types, and we have the design system here. We have tokens for our colors, breakpoints, and stuff. We have some helpers to do spacings and breakpoints. We have styles for the reset, documentation, and the components. Your inputs and your buttons probably look more or less the same across the whole application, and this is where are defined and everyone is using them. I think that was everything that I have to say. If you have any questions, I will happy. I'm Fadamakis in all social media, by the way, if you want to connect with me. If you have any questions, happy to answer them.
Thank you for your talk. You mentioned inside your features, there's something called composables, and I don't know about that.
I think it's a common pattern nowadays in Vue 3, and I think in React they also use composables. Let me show you an example.
Okay.
Hooks, okay. So it's basically state management, the way to do state management. It's stateful functions. They have the state and functionality way to abstract.
Two questions, if you don't mind. One, do you think this helps when working with larger teams, since everyone can just work on one feature and not have to necessarily go into some other files?
I think so, yes.
And my other questions, I'll make it.
Yeah, I have a question. How would you organize, if you know, on the Twitter,
Okay.
on the left side at the bottom, you had this profiles. Like, see your name, yeah, here.
Okay.
Where would you put it, and can you show how you organize it? Because it's part of the sidebar, but at the same same situation, it's a part of the profile, right? So like data fetching probably goes to profile.
Okay, good question. So this on the left is the header. I don't know. I know it's not in the header in the top, but the header can be anywhere, and it's common across every page. So if I go to my layout, I have the header here, and if I go somehow inside, let me. It's a features header. Let me go because I don't have. I'm having different header for each device, and then we have a user avatar that is imported from the profile. So yes, the header is uses something from the profile feature.
Do you have rules for imports? So how do you control how developers are importing from one module to another? Because regardless of the organization of the folders, if you don't set guardrails, our experience in our code base is that we ended up with importing everything from everything, and so having a big pool of money.
You can only import from the index file if that's what you mean. You can enforce this with CSLint rule. If you want to import something from another feature, you cannot. You can do it. I don't know if I understand the question.
Yeah, no, I was wondering if you have methods to limit the direction of imports and prevent a certain type of imports, like features can only import pages, but pages are not allowed to import anything from features or something like that.
I don't have that rule. It makes sense though. You cannot import the page. Every page should import only features. You could write a ESLint rule. I don't have one in place. But yes, it makes sense. It makes sense.
Thank you.
More question?
Yeah, can you please explain us, like, your testing strategy?
My testing strategy in this project doesn't exist, but yeah, of course, unit test, I don't think I have to convince you. I'm a big fan of visual tests. So basically, if you do a change, you need to approve it or not, if it breaks many things. Someone asked before if I will let my designer to change something, and this change will be automatically propagated in the code, which I think my designer will break everything if I let him do that. So a developer has to make the change. End-to-end tests as well. Everything run in pipeline and locally. I don't think I'm missing something. There are some more sophisticated, like mutation. Visual test is the one that I'm most fun with tools. I take 2 screenshots and compare.
What do we do with horizontal dependencies? Because as I see, you can import the modules on the same level. For example, in profile, in header, you can import from user from profile. Yeah, and it makes some horizontal dependencies. And in the future, for example, if you want to change your user avatar or move it in a place, you can broke their code or something like that.
You will just need to change your import in the index file if you move it. So this import will not change.
Okay, for example, what about API? For example, if your few features use the same API, the same request, what do? You just repeat them in every model, or you have like common place for?
The one that makes most sense should own it, and the other should consume it. So basically, the profile picture should maybe have the API logic, and maybe someone else will just import it from the profile. Do you have a better solution?
I prefer a common place for this feature. From my side, I agree with this architecture in most cases, but I prefer to separate API level to like features and other stuff.
This is what feature slice architecture also suggests, to have some shared folder, but then you have the gorilla banana problem. You ask something and you get everything with it. So it's when you start having inheritance, things will don't end up well, in my experience. But yeah, I get you.
Okay, thank you.
Great, thank you very
Thank you.
much.
Thank you.
Big round of applause.